Hello everyone, this is Vani from R.M.K College of Engineering and Technology. In this video, I am going to discuss about static electric fields. The fields which are the function of coordinates but which are not function of time are called as static fields. Also, the source charges are at rest. The objectives are to understand the history of Coulomb's law, to define Coulomb's law, to solve problem based on Coulomb's law. Any invention gives us enthusiasm and inspiration when we go through its history. Similarly, Coulomb's law in 1785, the French physicist Charles Coulomb published his first three reports of electricity and magnetism where he stated his law. The publication was essential to the development of theory of electromagnetism. He used a torsion balance to study the repulsion and attraction forces of charged particles and determined that the magnitude of electric force between 2-point charges is directly proportional to the product of charges and inversely proportional to the square of the distance between them. This is the experiment arrangement, and he is Mr. Coulomb. Now, Coulomb stated that the force between two very small objects separated in vacuum or free space by a distance which is large compared to their size is proportional to the charge on each and inversely proportional to the square of the distance between them. So, as a equation, it is represented as F is equal to K Q1 Q2 divided by R square. So in SI units, the quantities of charge Q are measured in Coulomb, the separation R in meters, and the force F should be in newtons. So this will be achieved if the constant of proportionality K can be written as 1 by 4 pi epsilon, where epsilon is nothing but the permittivity of free space and it is measured in farads per meter, and it has the magnitude of 8.854 into 10 power minus 12, equivalently 1 by 36 pi into 10 power minus 9, and the unit is farad per meter. So the Coulomb's law now, after substituting the value of proportionality constant K, it becomes F is equal to 1 by 4 pi epsilon Q1 Q2 by R square. So the force F acts along the line joining the two charges. If we see this diagram, the force F acts along the line joining the two charges. It is repulsive if the charges are alike. In this case, both the charges are alike. So the force is of kind repulsion. And it is attractive if the charges are of opposite sign. If we take here, Q1 and Q2 are of opposite sign. Therefore, the charges of the force created is of attraction. Now, if we would like to represent in vector form, the Coulomb's law can be represented as, if we take this diagram at this point, if we are willing to calculate the force F2 which is acting on Q2 because of Q1, then the expression is written as F2 is equal to 1 by 4 pi epsilon Q1 Q2 R12 square into A12, where A12 is the unit vector given by the expression R12 divided by magnitude of R12, or it is also can be represented as R2 minus R1 divided by magnitude of R2 minus R1, where R2 is the distance of at point Q2 from origin and R1 is the distance between origin and point Q1. So F2 is the force on Q2 for the case where Q1 and Q2 have the same sign, while A12 is the unit vector in the direction of R12, where R12 is a line segment from Q1 to Q2. So let us understand this law by solving a problem. It is given a charge Q1 is equal to 3 into 10 power minus 4 Coulomb at point M 1, 2, 3, and the charge of Q2 is equal to minus 10 raised to minus 4 Coulomb at N 2, 0, 5, and they are located in vacuum. Determine the force exerted on Q2 by Q1. So first of all, we know what is the equation. we have to calculate the force exerted on Q2 by Q1. So F2 is equal to 1 by 4 pi epsilon naught Q1 Q2 by R12 square into A12. If the question was suppose force exerted on Q1 by Q2, then we will calculate F1 and here it will become A21 and R21. So first in this equation, the unknown is A12 and R12. So we have to calculate both the values. R12 is nothing but R2 minus R1. If we take this expression, that is point M of 1, 2, 3, we can convert this into expression vector representation, which is 2ax bar, ay bar plus 5az bar, that is R2. R2 can be written as 2ax bar. There is no value for y, so just ay bar and 5az bar minus ax bar, 2ay bar, 3az bar, right? So if we subtract that, we will get ax bar minus 2ay bar plus 2az bar, and then we can calculate the unit vector, which is given by R12 divided by magnitude of R12. So we get this value. So if we substitute all the values, we know what is epsilon naught. It is 8.854 into 10 power minus 12. We know that Q1 is given by 3 into 10 power minus 4. Q2 is given by minus 10 power minus 4. So finally the answer for F2 is minus 10 AX bar plus 20 AY bar minus 20 AZ bar, and the unit of force is Newton. Now, in case if we are asked to find out F1 also, then F1 is always equal to minus F2, where we can just reverse the sign of F2. So as a summary, in this video, we have learned Coulomb's law and we have solved the problem based on Coulomb's law. Thank you.